ನಮಸ್ಕಾರ. ಕರ್ನಾಟಕ ಸರ್ಕಾರ ಮತ್ತು ಪದವಿ ಪೂರ್ವ ಶಿಕ್ಷಣ ಇಲಾಖೆಯಿಂದ ನಡೆಯುತ್ತಿರುವ ಜ್ಞಾನತರಂಗ CET ಮತ್ತು ನೀಟ್ ಕೋಚಿಂಗ್ ಕ್ಲಾಸ್ಗಳಿಗೆ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ 2018-19 ಕ್ಲಾಸ್ಗಳಿಗೆ ತಮಗೆ ವೆಲ್ಕಮ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ನಾನು ಶ್ರೀಧರ್ ಪ್ರಸಾದ್, ಕೆಮಿಸ್ಟ್ರಿ ಲೆಕ್ಚರರ್. Now I am going to discuss about the alcohols, phenols and ethers. Regarding synopsis, alcohols, they are hydroxy derivatives of alkanes. They are classified as monohydric, dihydric, trihydric, etc. Alcohols, depending upon whether they contain 1, 2, 3 ಎಕ್ಸೆಟ್ರಾ OH ಗ್ರೂಪ್ಸ್. ಅಂದರೆ ಒಂದು OH ಗ್ರೂಪ್ ಇದ್ದರೆ ಮೋನೋಹೈಡ್ರಿಕ್ ಆಲ್ಕೋಹಾಲ್ ಅಂತನೂ, 2 OH ಗ್ರೂಪ್ಸ್ ಇದ್ದರೆ ಡೈಹೈಡ್ರಿಕ್ ಆಲ್ಕೋಹಾಲ್ ಅಂತನೂ, 3 OH ಗ್ರೂಪ್ ಇದ್ದರೆ ಟ್ರೈಹೈಡ್ರಿಕ್ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಂತನೂ, 3ಕ್ಕಿಂತೂ ಜಾಸ್ತಿ ಇದ್ದರೆ ಪಾಲಿಹೈಡ್ರಿಕ್ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಂತನೂ ಕರೀತಾರೆ. ಪ್ರೈಮರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಲಿಂಕ್ಡ್ ಟು ಎನಿ ಒನ್ ಅದರ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಆರ್ ನೋ ಕಾರ್ಬನ್ ಆಟಮ್. ಪ್ರೈಮರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂದರೆ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮು ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಸೇರಿದರೆ ಇಲ್ಲ ಸೇರದಂತೂ ಇದ್ದರೆ ಅದನ್ನು ಪ್ರೈಮರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ಕರಿತೀವಿ. ಸೆಕೆಂಡರಿ ಕಾರ್ಬನ್ ಆಟಮ್, ಎ ಕಾರ್ಬನ್ ಆಟಮ್ ಲಿಂಕ್ಡ್ ಟು 2 ಅದರ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. ಬೇರೆ 2 ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಸೇರಿದರೆ ಅದನ್ನು ಸೆಕೆಂಡರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತನೂ. ಟೆರಿಷರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಲಿಂಕ್ಡ್ ಟು 3 ಅದರ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. ಒಂದು ಕಾರ್ಬನ್ ಆಟಮು 3 ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಸೇರಿದ್ರೆ ಅದನ್ನು ಟೆರಿಷರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ಕರಿತೀವಿ. ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಆಲ್ಕೋಹಾಲ್ಸ್. ದಿ ಹ್ಯಾಲೋ ಅಲ್ಕೇನ್ಸ್ ಆನ್ ಹೈಡ್ರಾಲಿಸಿಸ್ ವಿತ್ aqueous NaOH or KOH, it gives alcohols. Halo alkanes RX treated with NaOH, aqueous NaOH, gives rise to ROH plus NaX. ಹ್ಯಾಲೋ ಅಲ್ಕೇನ್ಸ್ ಅನ್ನ ಆಕ್ವಿಯಸ್ NaOH ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರುತ್ತೆ. ಹ್ಯಾಲೋ ಅಲ್ಕೇನ್ಸ್ ಆನ್ ಹೈಡ್ರಾಲಿಸಿಸ್ ವಿತ್ ಮಾಯಿಸ್ಟ್ ಸಿಲ್ವರ್ ಆಕ್ಸೈಡ್, ಇಟ್ ಫಾರ್ಮ್ಸ್ ಆಲ್ಕೋಹಾಲ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, halo alkanes treated with moist silver oxide gives rise to alcohols. Alkenes hydration with the concentrated sulfuric acid or boil with water also forms alcohols. Alkenes andre double bonded carbon atoms, CH2 double bond CH2 boiled with dilute H2SO4 or water, it forms CH3 CH2OH. ಯಾವ ಆಲ್ಕಿನ್ ತಗೊಂಡ್ರೆ ಅಷ್ಟೇ ನಂಬರ್ ಇರೋ ಕಾರ್ಬನ್ ಆಟಮ್ ನಂಬರ್ ಇರೋ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರುತ್ತೆ. ಈಗ ಈಥೀನ್ದಲ್ಲಿ 2 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದಾವ, ಬಂದಿರೋ ಪ್ರಾಡಕ್ಟ್ ಬಂದು 2 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಕಾಲ್ಡ್ ಎಥನಾಲ್ ಆರ್ ಈಥೈಲ್ ಆಲ್ಕೋಹಾಲ್. Alkenes gives primary, secondary, tertiary alcohols depending on the alkenes taken. Next, aldehydes on reduction with hydrogen in presence of nickel, it forms primary alcohol. For example, aldehydes. Reduction, addition of hydrogen atoms in presence of nickel or CH2OH. ಆಲ್ಡಿಹೈಡ್ಸ್ ಅನ್ನ ರಿಡಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರುತ್ತೆ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ನಿಕಲ್. ನೆಕ್ಸ್ಟ್, ಕೀಟೋನ್ಸ್ ಆನ್ ರಿಡಕ್ಷನ್ ವಿತ್ ಹೈಡ್ರೋಜನ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ನಿಕಲ್, ಇಟ್ ಫಾರ್ಮ್ಸ್ ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ketones on reduction in presence of nickel, it forms secondary alcohol. ಆಲ್ಡಿಹೈಡ್ಸ್ ಅನ್ನು ರಿಡಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರುತ್ತೆ, ಕೀಟೋನ್ಸ್ ಅನ್ನು ರಿಡಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್, alcohols can also be prepared by following methods, that is from Grignard reagent, hydroboration oxidation of alkenes, hydrolysis of esters. Example, hydrolysis of esters. For example, CH3COO C2H5 in presence of water, that is NaOH. CH3COOH plus C2H5OH. Alcohols can also be prepared by the hydrolysis of an ester in presence of NaOH. This reaction is also called as saponification. Properties. Alcohols are neutral substances. Lower members are colorless liquids, that is up to C4 carbon atoms. Higher members up to C11 are oily liquids. More than C11 carbon atoms are waxy solids. The boiling point increases with increase in molecular mass. The boiling point decreases with increase in branching. For example, boiling point increases with increase in molecular mass. As the number of carbon atoms goes on increasing, that is molecular mass increasing, boiling point also increases. Boiling point decreases with increase in branching. Branches ಜಾಸ್ತಿ ಆದ್ರೂ boiling point ಕಡಿಮೆ ಆಗುತ್ತೆ. Solubility of alcohols in water decreases with increase in molecular mass. Molecular mass of the compound ಜಾಸ್ತಿ ಆದರೆ solubility of alcohols in water, ನೀರಲ್ಲಿ ಕರಗುವ ಲಕ್ಷಣ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅಂದರೆ lower members are easily soluble in water, higher members are sparingly soluble in water. Solubility of alcohols in water is due to intermolecular hydrogen bonding with water. ಯಾವ ಕಾಂಪೌಂಡ್ಸ್ ನೀರಲ್ಲಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ನೀರಲ್ಲಿ ಸಾಲ್ಯುಬಿಲಿಟಿ ಆಗುತ್ತೋ ಅದು ಏನು ಹೇಳುತ್ತಪ್ಪ ಅಂದರೆ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ವಿತ್ ವಾಟರ್. Chemical properties. With metals, they liberate hydrogen gas. Alcohols or OH reacts with sodium like metals, forming sodium alkoxide plus hydrogen gas will be released. This example shows that alcohols easily produces H plus ions. Next, with the carboxylic acids, important one, they form esters by losing water molecule, that is called dehydration. This reaction is called esterification. For example, alcohols ROH plus RCOOH in presence of concentrated sulfuric acid, it forms an ester RCOOR plus water molecule. Alcohols reacts with carboxylic acids in presence of H2SO4. This H2SO4 is called as a dehydrating agent, helps us to remove the water molecule, and at the same time it acts as a catalyst, forming an ester RCOOR. With the Grignard reagent, that is RMGX, and on further hydrolysis, they form alkanes. RMGX plus R-OH gives rise to or OMGX or formation of alkanes takes place. Alcohols reacts with Grignard reagent, they form, on further hydrolysis, they form alkanes. On oxidation, that is with mild oxidizing agent, primary alcohols converts into aldehydes. These aldehydes further oxidation gives rise to carboxylic acids. Alcohols on oxidation, aldehydes. This is on further oxidation, carboxylic acids. Number of carbon atoms remains the same. For example, ethyl alcohol on oxidation forming acetaldehyde or ethanol. This is on further oxidation forming acetic acid or ethanoic acid. Ketones on further secondary alcohols on oxidation forms ketones. This is on further oxidation forming carboxylic acids. Note, alcohols on oxidation with strong oxidizing agents, they form carboxylic acids. If alcohols are treated with strong oxidizing agents like alkaline KMnO4, they form carboxylic acids. With haloalkanes, with HX, they form haloalkanes. Alcohols, when reacts with HX, in presence of anhydrous zinc chloride, elimination of water molecule takes place, forming haloalkanes. With PCl5, they also form haloalkanes. Alcohols reacts with PCl5, forming RCl plus HCl plus POCl3. Alcohols reacts with phosphorus pentachloride. They form haloalkane, that is alkyl chloride, hydrogen chloride and phosphorus oxytrichloride. With thionyl chloride, alcohols reacts with thionyl chloride, it forms RCl plus HCl plus SO2 gas. This method is called Dargens method. This method is preferable for the preparation of haloalkanes because among the products, out of 3 products, 2 are gases, they will escape out and you can prepare easily haloalkane by Dargens method. Hence, this method is preferable and easiest and fastest method. With catalytic dehydrogenation, when alcohol vapors are, primary alcohol vapors are passed over heated copper catalyst at 300 degrees centigrade, dehydrogenation takes place, forming an aldehyde and hydrogen gas will be liberated. If suppose secondary alcohols vapors are passed over heated copper catalyst at 300 degrees centigrade, ketones are formed with liberation of hydrogen gas. This reaction is called catalytic dehydrogenation. Here copper is the catalyst. At 300 degrees centigrade, hydrogen gas is liberated. Primary alcohols can be converted into aldehydes. Secondary alcohols are converted into ketones. Tertiary alcohols on catalytic dehydrogenation, they form aldehydes. Generally, tertiary alcohols do not undergo catalytic dehydrogenation at normal conditions. At drastic conditions, they undergo dehydrogenation, forming aldehydes. The reaction in which COH bond breaks, the reactivity of alcohols is primary greater than secondary greater than tertiary. Primary alcohols alli COH bond jaldi break agutte, secondary tertiary kantunu. The reactions in which CO bond, carbon oxygen naduve iro bond tertiary dalli jaldi break agutte, secondary and primary kantunu. If the OH group, next regarding phenols, if the OH group is directly linked to the benzene ring, they are called phenols. OH group direct benzene ring ge link ಆದರೆ ಈ ಕಾಂಪೌಂಡ್ಸ್ ಅನ್ನ ಸಪರೇಟ್ ಕಾಂಪೌಂಡ್ ಫಿನಾಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Preparation of phenols. With chlorobenzene and NaOH at 350 degrees centigrade, 300 atmospheric pressure, it forms phenol called Dawes process. Chlorobenzene plus NaOH, 350 degrees centigrade, 300 atmospheric pressure, cuprous chloride catalyst, it forms phenol. When benzene and propene in presence of oxygen and on acidification, it forms a phenol. This process is called Cumin process. Benzene plus cumin or isopropyl benzene, CH3CH propene in presence of anhydrous aluminum chloride, CH3. Isopropyl benzene is called cumin. This is on oxidation. It forms cumin hydroperoxide. Cumin hydroperoxide on acid hydrolysis, it forms phenol plus acetone. It is an important byproduct. Acetone is obtained by this method. Hence, phenol is manufactured in the industrial level by Cumin's method or Cumin's process. With aniline and HNO2 and on hydrolysis, aniline, HNO2 and dissolved in HCl, 0 to 5 degrees centigrade, it forms benzene diazonium chloride. This is on hydrolysis forms phenol and HCl and nitrogen gas will be liberated. Aniline nanna nitrous acid and HCl jote at 0 to 5 degrees ಮಾಡಿದ್ರೆ ಬೆಂಜಿನ್ ಡೈಅಜೋನಿಯಂ ಕ್ಲೋರೈಡ್ ಬರುತ್ತೆ. ಈ ಪ್ರಾಸೆಸ್ ಅನ್ನ ಡೈಅಜೋಟೈಸೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಬೆಂಜಿನ್ ಡೈಅಜೋನಿಯಂ ಕ್ಲೋರೈಡ್ ಫರ್ದರ್ ಹೈಡ್ರಾಲಿಸಿಸ್ ಫಾರ್ಮ್ಸ್ ಫಿನಾಲ್ಸ್ and liberates nitrogen gas. This reaction will take place aromatic primary amines. Properties. Phenols are acidic in nature. It is weaker than carbonic acid. Phenol produces H plus ion with the formation of phenoxide ion. This phenoxide ion, due to resonance and double bond, is more stable than phenol. So phenoxide ion is more stable than phenol and it produces H plus ion. Hence phenol is acidic in nature. Hence it is also called as Carboxylic acid. ಫಿನಾಲ್ ಇರೋ ಇನ್ನೊಂದು ಹೆಸರು ಏನಪ್ಪಾ ಅಂದ್ರೆ ಕಾರ್ಬೋಲಿಕ್ ಆಸಿಡ್. ಇದು ಲೈಫ್ ಬಾಯ್ಸ್ ಓಡರ್ ಸ್ಮೆಲ್ ಇರುತ್ತೆ. ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಲೈಫ್ ಬಾಯ್ ಓಡರ್ ಸ್ಮೆಲ್. ಇನ್ ಫಿನಾಲ್ OH group is linked to sp2 hybridized carbon atom. Due to its electron negativity, it readily loses H plus ion, forming phenoxide ion. The phenoxide ion is more stable due to resonance than phenol. Chemical reactions. With bromine water, it forms 2, 4, 6, tribromophenol. Phenol, when treated with bromine water, white precipitate of bromine water color discharged. Bromine water have a orange color, it is changes to white precipitate with the formation of idu first position 2, 4, 6, 2, 4, 6, tribromophenol having white precipitate. With bromine in presence of carbon disulfide, halogenation takes place, forming orthobromo and parabromophenol. Phenol, when treated with bromine in presence of carbon disulfide, that is halogen carrier, orthobromophenol, 1, 2 positions are ortho, 1, 4 positions are parabromophenol. So bromine in presence of carbon disulfide, that is halogen carrier, halogenation takes place, forming orthobromophenol and parabromophenol. Next, with dilute HNO3, it forms orthonitrophenol and paranitrophenol. Similarly, with the nitration mixer, that is concentrated HNO3 and concentrated H2SO4, it forms 2, 4, 6 trinitrophenol called picric acid. Important question, please. Phenol, when treated with concentrated HNO3 in presence of concentrated H2SO4, this mixer is called a nitration mixer. It forms first position nitro group, nitro group, nitro group. 2,4,6 trinitrophenol called picric acid, which is yellow in color, used in explosives. Picric acid used in explosives. Next, with chloroform and anhydrous aluminium chloride, it forms orthomethylphenol and paramethylphenol. This reaction is called Friedel-Crafts reaction. Coal-based reaction. Phenol treated with NaOH and carbon dioxide at 6 to 7 atmospheres at 130 degrees centigrade, it forms sodium salicylate. It is on further acidification forms salicylic acid. Phenol treated with NaOH, it forms sodium phenate. This is further treated with carbon dioxide, 130 degrees centigrade, 6 to 7 atmospheres. It forms sodium salicylate. It is on acid hydrolysis, forms salicylic acid. This reaction is called as coal-based reaction. Phenol is converted into salicylic acid with NaOH, carbon dioxide at 130 degrees centigrade, 6 to 7 atmospheres in presence of an HCl, that is acid hydrolysis. Next, Rhimertimen reaction. Phenol plus sodium hydroxide and chloroform, and on further acidification it forms a salicylaldehyde. Phenol plus sodium hydroxide plus carbon tetrachloride, and on further acidification it forms salicylic acid. The difference is, if you have taken chloroform, salicylaldehyde. If you would have taken carbon tetrachloride, salicylic acid. Among these two, the electrophile is CCl2 is the electrophile which attacks to the phenol, forming either salicylaldehyde or salicylic acid. Phenol on heating with zinc dust, it forms benzene. It is easy method to eliminate phenolic OH group. ಫಿನಾಲ್ದಲ್ಲಿರೋ OH ಗ್ರೂಪ್ ಅನ್ನ ಈಸಿಯಾಗಿ ತೆಗಿಬೇಕು ಅಂದ್ರೆ ಜಿಂಕ್ ಡಸ್ಟ್ ಲಿಂದ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಸಾಕು. OH group eliminates and forms benzene. Zinc dust is the material which is used to eliminate phenolic OH group. Phenol plus phthalic anhydride plus NaOH, it forms an acid-base indicator, phenolphthalein, which is used in acid-base titration, which produces pink color. Phenol plus phthalic anhydride and NaOH. It produces an acid-base indicator called phenolphthalein, which is pink in color. Phenol plus formaldehyde on heating, it forms a plastic called bakelite. Phenol on oxidation with chromic oxide, it forms benzoquinone. Ethers, they have the general formula RCOR. They can also be treated as alkyl derivatives of monohydric alcohol. That is, if hydrogen atom of OH group of alcohol replaced by alkyl group, ಇದು ಆಲ್ಕೋಹಾಲ್ ROH. ಈ ಹೈಡ್ರೋಜನ್ ಅನ್ನ replaced with alkyl group, this forms ether. These are alcohols, these are ethers. If both R and R same, ER same ಇದ್ರೆ ಸಿಂಪಲ್ ಈಥರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ER ಡಿಫರೆಂಟ್ ಇದ್ರೆ ಮಿಕ್ಸ್ಡ್ ಈಥರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. both alkyl groups are same, then it is called simple or symmetrical ethers. If both alkyl groups are different, then it is called mixed or unsymmetrical ethers. Preparation of ethers. Williamson's ether synthesis. The sodium alkoxide treated with the haloalkane, it forms ether. Sodium alkoxide RONA plus alcohol ROH gives rise to elimination of NaOH, haloalkane, or OR plus NaX. Sodium alkoxide treated with the haloalkane, it forms ethers. Dehydration of alcohol. The alcohols heated with the concentrated sulfuric acid in the ratio 2:1 at 413 Kelvin, it undergoes dehydration forming ethers. Alcohols, concentrated sulfuric acid. ನಿಮಗೆಲ್ಲ ತಿಳಿದ ಹಾಗೆ concentrated sulfuric acid helps us to remove the water molecule. Two molecules, one molecule sulfuric acid, 413 Kelvin or CROR plus water. Alcohols and sulfuric acid in the ratio 2:1 on heating at 413 Kelvin undergoes dehydration forming ethers. Properties. Due to presence of lone pair of electrons on oxygen atom of ether, they act as Lewis bases. Ethers alli iro oxygen atom mele they have two lone pair of electrons. These are electron donors. As per the Lewis theory, electron donors are called Lewis bases. Ethers have low boiling point than alcohols. Alcohols kantunu ethers have low boiling point. Chemical properties. With the HI, the halogen atom linked to smaller alkyl group in case of mixed ether, and it takes place according to SN2 mechanism, and it is controlled by steric factor. For example, CH3O, CH2CH3 plus HI. HI H ಯಾವ ಕಡೆಗೆ ಹೋಗಬೇಕು, I ಯಾವ ಕಡೆಗೆ ಹೋಗಬೇಕು. Halogen will be attacked to less number of alkyl groups. Hydrogen will be the with oxygen atom. CH3I plus CH3 CH2OH. This is controlled by SN2 mechanism and steric factor. Once again please, halogen will be attacked to lower member of alkyl groups and hydrogen will be with oxygen atom to the higher members, forming CH3I, CH3, CH2OH. This is possible only in case of unsymmetrical ethers or mixed ethers. Now we will discuss some questions. Lucas reagent. ತಮಗೆಲ್ಲಗೂ ತಿಳಿದ ಪ್ರಕಾರ ಲೂಕಸ್ ರಿಯೇಜೆಂಟ್ ಅಂದ್ರೆ it is a mixture of concentrated HCl and anhydrous zinc chloride. ಇದನ್ನ ಪ್ರೈಮರಿ, ಸೆಕೆಂಡರಿ, ಟೆರಿಷರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ಮಾಡ್ಲಕ್ಕ. ಟೆರಿಷರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಪ್ರೊಡ್ಯೂಸಸ್ ದಿ ವೈಟ್ precipitate instantaneously. Secondary alcohols produces after 5 or 10 minutes. Primary alcohols produces only after heating. So the order of reactivity with Lucas reagent with alcohols is tertiary greater than secondary greater than primary. tertiary greater than secondary greater than primary. Tertiary alcohols produces white precipitate instantaneously with Lucas reagent. Secondary alcohols produces white precipitate after 5 minutes. Primary alcohols produces precipitate after heating. So Lucas reagent is a mixture of concentrated HCl anhydrous zinc chloride. So the answer is A. Next, cyclohexanol is a phenol, primary alcohol, secondary alcohol, tertiary alcohol. Cyclohexanol. Idu cyclohexanol. Cyclo means ring structure, hex means 6 carbon atoms, AN means single bond, OL means OH group. Idu phenol alla. Reason is ಒಳಗಡೆ double bonds illa. Primary alcohol or secondary alcohol, tertiary alcohol. As you know, OH group attached carbon atom contains or it attaches to 2 other remaining carbon atoms. ಈ ಕಾರ್ಬನ್ ಆಟಮು ಇನ್ನ ಉಳಿದಿದ್ದ 2 ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಲಿಂಕ್ ಆಗಿರೋದ್ರಿಂದ ಇದನ್ನು ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ ಅಂತ ಕರಿತೀವಿ. ಸಾಕಷ್ಟು ಜನ ನೋಡಿದ ತಕ್ಷಣ ಇದನ್ನ ಫಿನಾಲ್ ಅಂತಾರ. ಒಳಗಡೆ ರಿಂಗ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಸೈಕ್ಲೋಹೆಕ್ಸನಾಲ್. ಇಟ್ ಈಸ್ ಆಲ್ಸೋ an alcoholic belongs to alcoholic family. So answer is C, secondary alcohol. The alcohol manufactured from water gas, carbon monoxide and hydrogen in presence of zinc oxide and chromic oxide is a promoter. It forms methyl alcohol. ಯಾವ ಆಲ್ಕೋಹಾಲ್ ಅನ್ನು ನಾವು ವಾಟರ್ ಗ್ಯಾಸ್ ಇಂದ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರಿಂಗ್ ಮಾಡಬಹುದಪ್ಪ ಅಂದ್ರೆ ಮೆಥನಾಲ್ ಅನ್ನು ಮಾಡಬಹುದು. ಮೆಥನೋಲ್ ಆರ್ ಮಿಥೈಲ್ ಆಲ್ಕೋಹಾಲ್. The 4 alcohols ABCD have 3, 2, 1 and 0 alpha hydrogen atoms. Very interesting question. The 4 alcohols ABCD, 4 alcohols ಅಲ್ಲಿ 3 ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಎ ದಲ್ಲಿನು, 2 ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಸಿ ದಲ್ಲಿನು, ಬಿ ದಲ್ಲಿನು, 1 ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಸಿ ದಲ್ಲಿನು, ಯಾವ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇಲ್ಲದಂತ ಡಿನು ಇದಾವ. ವಿಚ್ ಆಫ್ ದೀಸ್ ವಿಲ್ ನಾಟ್ ರೆಸ್ಪಾಂಡ್ ಟು ವಿಕ್ಟರ್ ಮೇಯರ್ಸ್ ಟೆಸ್ಟ್. ವಿಕ್ಟರ್ ಮೇಯರ್ಸ್ ಟೆಸ್ಟ್ ಅನ್ನೋದು ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಕಂಡುಹಿಡಿಯಲಕ್ಕೆ ಯೂಸ್ ಮಾಡೋ ಟೆಸ್ಟ್. ಇದರಲ್ಲಿ ಯಾವುದಕ್ಕೆ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲ? ಡಿ ಆಲ್ಕೋಹಾಲ್ಗೆ ಇಲ್ಲ. ಸೊ ಆನ್ಸರ್ ಈಸ್ ಡಿ, ವಿಚ್ ಡು ನಾಟ್ ಕಂಟೈನ್ಸ್ ಆಲ್ಫಾ carbon atom, hence it is not answered by the Victor-Meyer's test. So once again, Victor-Meyer's test is used to test alpha carbon atoms in the hydro alcohols. So compound D dalli alpha hydrogen atoms illa, idu Victor-Meyer test ge answer madangilla. So answer is D. Next, power alcohol is a mixture of petrol and alcohol in the ratio petrol 80%, alcohol ethyl alcohol 20% ಅನ್ನ ನಾವು ಪವರ್ ಆಲ್ಕೋಹಾಲ್ ಅಂತ ಕರಿತೀವಿ. ಅಲ್ಲಿ ಇರೋ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ 4:1, 1:4, ಪೆಟ್ರೋಲ್ 80%, ethyl alcohol is 20%. Among the 4 options, the first option is suitable, hence answer is 1, 4:1. Next, methylated spirit is, options are methanol, methanol and ethanol, methanoic acid, methanamide. ಈ 100% ಅಬ್ಸಲ್ಯೂಟ್ ಆಲ್ಕೋಹಾಲ್ ಅನ್ನ ಮಿಸ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರಾ, ಡ್ರಿಂಕಿಂಗ್ ಪರ್ಪಸ್ ನಾಟ್ ಟು ಬಿ ಯೂಸ್ಡ್ ಅಂತ ಹೇಳಿ ಇದಕ್ಕೆ 5% ಆಫ್ ಮೀಥೈಲ್ ಆಲ್ಕೋಹಾಲ್ ಅನ್ನು ಸೇರಿಸ್ತಾರೆ. 95.5% ಆಫ್ ಈಥೈಲ್ ಆಲ್ಕೋಹಾಲ್ಗೆ 5% ಆಫ್ ಮೀಥೈಲ್ ಆಲ್ಕೋಹಾಲ್ ಸೇರಿಸಿ, ವಿಚ್ ಈಸ್ ಅನ್ಫಿಟ್ ಫಾರ್ ದ ಡ್ರಿಂಕಿಂಗ್ ಪರ್ಪಸ್, ಈಸ್ ಕಾಲ್ಡ್ ಮೆಥಿಲೇಟೆಡ್ ಸ್ಪಿರಿಟ್. ಅಂದ್ರೆ ಮೆಥಿಲೇಟೆಡ್ ಸ್ಪಿರಿಟ್ ಅಲ್ಲಿ ಮೆಥನಾಲ್ ಪ್ಲಸ್ ಎಥನಾಲ್ ಎರಡು ಇರೋದ್ರಿಂದ ಇದನ್ನು ಮೆಥಿಲೇಟೆಡ್ ಸ್ಪಿರಿಟ್ ಅಂತ ಕರೀತಾರೆ. ಮೆಥನಾಲ್, ಆಸ್ ಯು ನೋ, ಮಿಥೈಲ್ ಆಲ್ಕೋಹಾಲ್, ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್, ನಥಿಂಗ್ ಬಟ್ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್, ಮೆಥನಮೈಡ್, it is other different compound. Answer is B. Next, arrange the following compounds in the increasing order of their boiling points. Propane 1 mole, butane 1 mole, butane 2 mole, pentane 2 mole. As per the synopsis, higher members are having high boiling point. ಯಾವ ಎಷ್ಟು ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಅದು ಹೈಯೆಸ್ಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಇಲ್ಲಿ ಪ್ರೋಪೇನ್ದಲ್ಲಿ 3 ಕಾರ್ಬನ್ ಆಟಮು, ಬ್ಯೂಟೇನ್ದಲ್ಲಿ 4 ಕಾರ್ಬನ್ ಆಟಮು, ಪೆಂಟೇನ್ದಲ್ಲಿ 5 ಕಾರ್ಬನ್ ಆಟಮ್ ಇದಾವೆ. ಸೊ ಪೆಂಟೇನ್ ವಿಲ್ ಹ್ಯಾವ್ ಡೆಫಿನೆಟ್ಲಿ ಹೈ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಸೊ ಆಸ್ ಪರ್ ದ ಆನ್ಸರ್ಸ್, ಎ ಬಿ ವಿಲ್ ಬಿ ಓನ್ಲಿ ದಿ 2 ಆನ್ಸರ್ಸ್. ಸಿ ಅಂಡ್ ಡಿ ರಾಂಗ್ ಆನ್ಸರ್ಸ್. ಎ ಬಿ ದಲ್ಲಿ ಪೆಂಟೇನ್ 2 ಓಲ್ ಅಟ್ ದಿ ಎಂಡ್, ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಇದಾವ ಹೈಯೆಸ್ಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಪ್ರೋಪೇನ್ ಮುಂದೆ ಇದೆ, 3 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್, 3 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಟು ದಿ ಬ್ಯೂಟೇನ್ 2 ಓಲ್, ಬ್ಯೂಟೇನ್ 1 ಓಲ್, ಬ್ಯೂಟೇನ್ 1 ಓಲ್, ಬ್ಯೂಟೇನ್ 2 ಓಲ್. ಬ್ರಾಂಚಿಂಗ್ ಇಲ್ಲ, ಎರಡೂ ಐಸೋಮೆರಿಕ್ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಸೇಮು, ನಂಬರ್ ಆಫ್ OH ಗ್ರೂಪು ಸೇಮು ಇದ್ದು ಪೊಸಿಷನ್ಸ್ ಮಾತ್ರ ಬೇರೆ ಇದ್ರೆ, OH ಗ್ರೂಪ್ ಪೊಸಿಷನ್ಸ್, ಅಂತ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅನ್ನ ಐಸೋಮೆರಿಕ್ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇದು ಬ್ಯೂಟೇನ್ 2 ಓಲ್, ಇದು ಬ್ಯೂಟೇನ್ 1 ಓಲ್. Both the compounds are having same molecular formula. Only position of OH group will differ. This is primary alcohol, this is secondary alcohol. ಈ ಎರಡನ್ನ ಐಸೋಮೆರಿಕ್ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ ಕೇಸ್ ಆಫ್ ಐಸೋಮೆರಿಕ್ ಆಲ್ಕೋಹಾಲ್ಸ್, 1 naught is greater than 2 naught is greater than 3 naught with respect to boiling points. ಅಂದ್ರೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ is more than the secondary than the tertiary. ಸೊ ಇಲ್ಲಿ ಎ ಬಿ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಪ್ರೋಪೇನ್ 1 ಓಲ್ ಎರಡು ಕೇಸು ಸೇಮ್ ಇದಾವ. ಬ್ಯೂಟೇನ್ 2 ಓಲ್ ಸೆಕೆಂಡರಿ, ಬ್ಯೂಟೇನ್ 1 ಓಲ್ ಪ್ರೈಮರಿ, pentane 2 ಓಲ್. ಸೊ ಎ ಆನ್ಸರ್ ಈಸ್ ಕರೆಕ್ಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿ 1 ಫ್ಯಾಕ್ಟರ್, pentane highest number. Second factor, tertiary alcohols as the butane 2-ol is the secondary alcohol, butane 1-ol is the primary alcohol. So as per order, primary alcohol is higher boiling point, secondary alcohol is lower boiling point. A option is correct. Which of the following combinations can be used to synthesize isopropyl alcohol? Isopropyl alcohol from Grignard reagent by treating with methyl magnesium iodide and ethyl formate. By these combinations, we can prepare isopropyl alcohol CH3, CHOH, CH3. This is obtain an intermediate product. This is on further hydrolysis. You are going to get isopropyl alcohol. Answer is D. Ethyl alcohol can be prepared from Grignard reagent by the reaction. ಇಲ್ಲಿ 4 ಆಪ್ಷನ್ಸ್. ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಫಸ್ಟ್ ಒನ್, ಕೀಟೋನ್, ಅಲ್ಕೇನ್ ನೈಟ್ರೈಲ್, ಆಸಿಡ್ ಕ್ಲೋರೈಡ್. ಈ ಆಸಿಡ್ ಕ್ಲೋರೈಡ್ ಅಲ್ಲಿ 6 ಬಗ್ಗೆ ಗೊತ್ತಿಲ್ಲ, ಅಲ್ಕೇನ್ ನೈಟ್ರೈಲ್ ಅಲ್ಲಿನೂ 6 ಬಗ್ಗೆ ಗೊತ್ತಿಲ್ಲ, ಕೀಟೋನ್ದಲ್ಲಿನೂ 6 ಅಲ್ಲಿ ಎಷ್ಟು ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದಾವೆ ಅನ್ನೋದು ಗೊತ್ತಿಲ್ಲ. ಸೊ ಲಾಸ್ಟ್ ಅಂಡ್ ಕನ್ಕ್ಲೂಷನ್ ಆನ್ಸರ್ ಈಸ್ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್. Formaldehyde with Grignard reagent CH3MgI plus HCHO treated HCH3OMgI. This is on further hydrolysis. CH3 CH2OH plus basic magnesium iodide will be formed. So this is the only one answer we can easily identify, because we do not know the number of carbon atoms here, the number of carbon atoms here in the B as well as the C. So formaldehyde is the answer. Which of the following compounds does not react with sodium hydroxide? Sodium hydroxide ಜೊತೆ react ಆಗದಂತ ಇರೋ compounds ಯಾವು? First one, acetic acid or ethanoic acid. The name itself indicates is a carboxylic acid easily reacts with the bases. Sodium hydroxide andre it nothing but a base. Next, acetamide. It is a derivative of an acid. It also easily reacts with sodium hydroxide. Phenol. Phenol is also weak acid. It is also called as carbolic acid. Hence, it also reacts with NaOH, forming sodium phenoxide. Next, ethyl alcohol or ethanol. It is a neutral substance. It does not react with NaOH. This is the answer. So D, ethyl alcohol, alcohols do not react with NaOH. Next, which bond of ethyl alcohol undergoes cleavage during its reaction with sodamide? Sodamide is a derivative of ROH, NaNH2. ಆಲ್ಕೋಹಾಲ್ಸ್ ಸೋಡಮೈಡ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದರೆ ಯಾವ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ? ಕಾರ್ಬನ್ ಅಂಡ್ ಆಕ್ಸಿಜನ್ ಬಾಂಡ, ಆಕ್ಸಿಜನ್ ಅಂಡ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ? ಎಲಿಮಿನೇಷನ್ ಆಫ್ NH3. So the bond between oxygen and hydrogen will breaks up, forming RONA plus NH3. So sodamide jote react adre alcohols, the bond breaken will be takes place in between O and H. That cleavage takes place. Dehydration of 2-butanol yields. Dehydration of 2-butanol. CH3, CHOH, CH2, CH3. This is 2-butanol. OH ಅಂತು ಈ ಕಾರ್ಬನ್ ಆಟಮ್ನಿಂದ ತೆಗೆದಿದ್ಮೇಲೆ ಹೈಡ್ರೋಜನ್ ಎಲ್ಲಿ ತೆಗಿಬೇಕು? ಐದರ್ ದಿಸ್ ಒನ್ ಆರ್ ದಿಸ್ ಒನ್. ಯಾವ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ನಿಂದ ತೆಗೆದು? ಸೊ ಜನರಲಿ ಬೋತ್ ದ ಕಾಂಪೌಂಡ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್. CH ಇಲ್ಲಿ ತೆಗೆದ್ರೆ CH2, CH3 ಒನ್ ಕಾಂಪೌಂಡ್. ಈ ಕಡೆ ತೆಗೆದ್ರೆ CH2 ಡಬಲ್ ಬಾಂಡ್ CH, CH2, CH3. If you remove alpha hydrogen from here or here, both the compounds will be formed. So answer 1 butene, 2 butene, 2 butane, both 1 and B. As per the reaction, we have already discussed it. It is answer is D, A and B. Both A and B. D is the answer. Next question. The correct order of increasing basicity of the following acids. Methyl alcohol, first water, OH minus base, CH3OH methyl alcohol, CH3O methoxide ion. Alcohols are weaker acids than water. Alcohols weaker acids than water. Alcohols stronger bases than water. So order is acids, water, alcohols. Alcohols are weaker acids than water. Alcohols are stronger bases than water. Now water is a neutral. OH minus hydroxyl ion, CH3OH alcohol, CH3O minus methoxide ion. Which is the order? Basicity, increasing basicity. Which is more basic? As per the statements, answer C, water less than methyl alcohol, less than hydroxyl ion, less than methoxide ion. Alcohols are weaker acids than water. Alcohols are stronger bases than water. So basicity is more in case of methoxide ion. So answer C, option C is correct method. Among the compounds, strongest acid is first one is acetylene or ethine, next to benzene, next to ethane, next methyl alcohol. Methyl alcohol on ionization produces methoxide ion and H plus ion. Among the four options, 4 options allinu observe madidre methoxide ion will produce as H plus ion, hence it is strongest acid. So answer is D. Phenol is more readily soluble in. Phenol is acidic in nature. It is on ionization, it produces phenoxide ion and H plus ion. This indicates phenol is acid. It is called as carbolic acid. I already discussed it. So acids are generally soluble in sodium bases like sodium hydroxide and diluted Cl, both sodium hydroxide and diluted Cl, and sodium bicarbonate solution. So easily soluble in sodium hydroxide. Answer is A. Next, Which of the following molecules has sufficient C double bond O double bond character? ಯಾವ ಕೆಳಗೆ 4 ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿನೂ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಕ್ಯಾರೆಕ್ಟರ್ ಇದೆ? ಫಿನಾಲ್, ಸಿ ಡಬಲ್ ಬಾಂಡ್, ಆರ್ಥೋಕ್ರಿಜಾಲ್, ಪ್ಯಾರಾಕ್ರಿಜಾಲ್, all have C double bond O double bond character. ಎಲ್ಲದರಲ್ಲಿನೂ ಫಿನಾಲ್ದಲ್ಲಿ, ಆರ್ಥೋಕ್ರಿಜಾಲ್ದಲ್ಲಿ, ಪ್ಯಾರಾಕ್ರಿಜಾಲ್ದಲ್ಲಿ all will have double bond character. So answer is D. Phenol, though acidic, cannot decompose sodium bicarbonate because phenol is a phenol acid. Doubt illa adaralli. It is also called as carboxylic acid. Carbolic acid. But it do not decompose sodium bicarbonate. Generally, when we write the order of acidic strength, phenol is higher, sodium bicarbonate is lower. Phenol is more stronger than the sodium bicarbonate. Sorry, please. Sodium bicarbonate and phenol. ಇದು order of reactive acidic strength of the acids. Sodium bicarbonate or carbonic acid. ಇದು carbolic acid. Carbolic acid, phenol is weaker than carbonic acid. Hence, it cannot liberate or dissolve or decompose sodium bicarbonate solution. Carbonic acid is stronger than phenol. Answer is B. Phenol is weaker than carbonic acid. Next. Cumin on reaction with oxygen followed by hydrolysis gives cumin, isopropyl benzene is called cumin, which is on oxidation it forms cumin hydroperoxide. This is on acidification forms phenol and acetone. Cumin on reaction with oxygen followed by hydrolysis gives phenol and acetone. So answer, first one is methyl alcohol and acetone. Second one is phenol and dimethyl ether. Third one, methyl phenyl ether and methyl alcohol. D option is phenol and acetone. So appropriate answer is D. The IUPAC name of IUPAC name. So we should give numbers to the carbon atoms 1, 2, 3, 4, 5. From here also we can give, but two substituents are present here. ಸೊ ದಟ್ ಶುಡ್ ಗೆಟ್ ಎ ಲೀಸ್ಟ್ ನಂಬರ್. ಎರಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಇರೋದ್ರಿಂದ ಇದಕ್ಕೆ ಲೋಯೆಸ್ಟ್ ನಂಬರ್ ಬರಬೇಕು. ಸೊ ಆಟೋಮ್ಯಾಟಿಕಲಿ ಆ ನಂಬರ್ ಇನ್ಕ್ರೀಸ್. ಎರಡನೇ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ OH ಗ್ರೂಪ್ ಇದೆ, ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇದೆ. ಫೋರ್ತ್ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ OH ಗ್ರೂಪ್ ಇದೆ. 5 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದಾವ ಪೆಂಟ್. ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ 2 ಮಿಥೈಲ್. ಇನ್ನ OH ಗ್ರೂಪ್ಸ್ ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಗೂ ಫೋರ್ತ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇದಾವ 2,4 ಡೈ ಪೆಂಟ್ ಕನೆಕ್ಟೆಡ್ ವಿತ್ ಸಿಂಗಲ್ ಬಾಂಡ್ ANE. ಎರಡು OH ಗ್ರೂಪ್ಸ್ ಇರೋದ್ರಿಂದ ಡೈಓಲ್. ಒನ್ಸ್ ಅಗೈನ್ ಇಲ್ಲಿ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಇದಾವ. ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ 2 ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸು, 4ನೇ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್. ಜಾಸ್ತಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಇರೋ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಲೋಯೆಸ್ಟ್ ನಂಬರ್ ಬರಬೇಕು. ಸೊ ಈ ಕಡೆಲಿದ್ದ ಕೊಟ್ರೆ 1, 2, 3, 4, 5. ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇದೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಆಗಿ. 5 ಕಾರ್ಬನ್ ಆಟಮ್ ಇದಾವ ಪೆಂಟ್ ಕನೆಕ್ಟೆಡ್ ವಿತ್ ಸಿಂಗಲ್ ಬಾಂಡ್ ANE. 2 OH ಗ್ರೂಪ್ಸ್ ಇದಾವ ಡೈವೋಲು. ಬೋತ್ ದ ಗ್ರೂಪ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಅಟ್ ಸೆಕೆಂಡ್ ಅಂಡ್ ಫೋರ್ತ್. ಸೊ ದೀಸ್ ಆರ್ ಲೊಕೆಂಟ್ಸ್. ಒನ್ಸ್ ಅಗೈನ್ 2 ಮಿಥೈಲ್, 2,4 ಪೆಂಟ್, pentane, diol. 1,1 dimethyl, 1,3 butane diol. Wrong answer. Pentane is the parental chain. 2 methyl, 2,4 pentane diol. Correct one. 4 methyl, 2,4 pentane diol. So substituents ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರ್ತಾವೋ that should get lowest number. 1,3,3 trimethyl, 1,3 propane diol. Wrong answer. So appropriate one is B. The strongest acid among the following aromatic compounds: orthonitrophenol, paranitrophenol, parachlorophenol, metanitrophenol. As we discussed earlier, phenol is acidic in nature, as the nitro group is electronic withdrawing group, which increases the acidic strength of the phenol. Orthonitrophenol, paranitrophenol, metanitrophenol. Parachlorophenol. Among all these compounds, para position, meta position formation of metanitrophenol is very chances are less. Orthonitro, paranitrophenol, among these two, in case of orthonitrophenol, there is a chance of formation of hydrogen bonding. Hence, it is also less acidic. Paranitrophenol is more acidic. When benzene diazonium chloride in aqueous solution heated, the product is benzene diazonium chloride. On heat hydrolysis, the product obtained is phenol. An alcohol A gives Lucas test within 5 minutes. This statement indicates that 5 minutes ಆದ್ಮೇಲೆ precipitate ಕೊಡ್ತಾ ಇದೆ ಅಂದ್ರೆ compulsory the alcohol will be secondary alcohol. 7.4 grams of alcohol when treated with sodium metal liberates 1120 ml of hydrogen gas at STP. What will be the alcohol? As per the statement, number of moles of hydrogen is equal to number of moles of alcohols. ಈ ಕೆಳಗೆ ಕೊಟ್ಟಿರೋ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವುದು ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್? ಬಿಕಾಸ್ ದ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಟ್ ಸೆಲ್ಫ್ an alcohol A gives Lucas test within 5 minutes. That indicates it is a secondary alcohol. Secondary alcohol are B and D. Among these two, 7.4 divided by molecular mass is equal to 1120 divided by 11,200 at STP. After calculation or simplifying, the molecular mass of the compound is 74. Molecular mass of the compound according to the formulas which are on the screen. B and C, D are the secondary alcohols. In this one, the molecular mass is 74 pertaining to answer B. Parasulfonic acid phenol on bromination produces parasulfonic acid phenol on bromination or treated with bromine water. Halogenation takes place at 3rd and 5th positions. So this is first position, 3rd, 5th, 3,5 dibromo 4 hydroxy benzene sulfonic acid. In the following reaction sequence, identify Z. Phenol treated with carbon tetrachloride and NaOH. Phenol with carbon tetrachloride, CCl4 with NaOH. It forms as per salicylic acid. This reaction is called Rhimertimen reaction. This is on further treated with zinc dust. OH group of the phenol will be phenolic OH group can be eliminated easily, forming benzoic acid. Benzoic acid further treated with soda lime, sodamide, undergoes decarboxylation. Carbon dioxide tagadu bitre it obtained is benzene. Once again, phenol treated with carbon tetrachloride and NaOH. It forms salicylic acid. This already discussed in the synopsis. This reaction is called Rhimertimen reaction. Salicylic acid further heated with zinc dust. Elimination of OH group, phenolic OH group takes place, forming benzoic acid. Benzoic acid further heated with sodamide or soda lime. Decarboxylation takes place, forming benzene. So answer is Z, benzene. The acidic nature of phenol is due to its ability to give proton, andre H plus kodutte. More electronegative nature of sp2 hybridized carbon atom of benzene ring, adunu correct, sp2 double bonded. Higher stability of phenoxide ion than phenol molecule, all these correct. So answer is D, ಎಲ್ಲವೂ ಕರೆಕ್ಟೇ. Which of the following species can act as strongest base? OH, OR, OC6H5, none of these. OR, OH, less basic, OR, or donor of electrons, so it is more basic. Benzyl alcohol is obtained from benzaldehyde. That's important question. Benzaldehyde on treated with strong solution of NaOH, as you studied in the synopsis, benzaldehyde undergoes reduction forming benzyl alcohol, and one molecule of benzaldehyde undergoes oxidation forming sodium benzoate. This reaction is called as Kenneger-Roche reaction. Kenneger-Roche reaction takes place only when aldehydes does not contain alpha hydrogen atom. ಯಾವ ಆಲ್ಡಿಹೈಡ್ಸ್ಗೆ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರಂಗಿಲ್ವೋ ಆ ಆಲ್ಡಿಹೈಡ್ಸು ಅಂಡರ್ಗೋಸ್ Kenneger-Roche reaction. During Kenneger-Roche reaction, one molecule of aldehyde undergoes oxidation forming sodium benzoate. One molecule of aldehyde undergoes reduction forming benzyl alcohol. So, the name of the reaction is Kenneger-Roche reaction. The hybrid state of carbon atom carrying OH group in phenol is, phenol ದಲ್ಲಿರೋ OH group ಅಲ್ಲಿ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಯಾವ hybridization? Due to presence of double bond, we can say easily sp2 hybridization. sp ಆದರೆ ಟ್ರಿಪಲ್ ಬಾಂಡು, sp3 ಆದರೆ ಸಿಂಗಲ್ ಬಾಂಡು. Identify the final product of the sequence. Phenol heated with zinc dust. So, phenol ಅನ್ನ zinc dust ಲಿದ್ದ heat ಮಾಡಿದ್ರೆ it forms benzene. Benzene further treated with CH3COCl in presence of anhydrous aluminum chloride called Friedel-Crafts reaction. Alkyl group attaches to group benzene ring form acetophenone or phenyl methyl ketone or phenyl ethanone. Acetophenone, an aromatic ketone, will be formed. Ethanol and dimethyl ether form pair of functional isomers. The boiling point of ethanol is higher than that of the dimethyl ether due to presence of CH3 CH2OH. Dimethyl ether CH3OCH3. Both the compounds have same number of carbon atoms, same number of hydrogen atoms, same number of oxygen atoms. They are isomers. But ethyl alcohol, ethanol boiling point is higher than that of the dimethyl ether. Reason: alcohols are soluble in water due to presence of or formation of hydrogen bonding with water. So, answer A, hydrogen bonding in ethanol, hydrogen bonding in dimethyl ether, CH3 group in ethanol, CH3 group in dimethyl ether. So, appropriate answer is hydrogen bonding in ethanol. Phenol and benzoic acid can be distinguished by phenol hero is special property, phenolic OH group. This will does bala acidic in nature, bala weak in nature. Hence, it does not decompose or liberate carbon dioxide from sodium bicarbonate solution. Hence, phenol and benzoic acid and ಎರಡನ್ನ sodium bicarbonate ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ So benzoic acid can liberate carbon dioxide from sodium bicarbonate. Phenol does not. So answer is sodium bicarbonate. Hybrid state of central oxygen atom in ether. Single bond ಇರೋದ್ರಿಂದ ಎರಡು ಕಡೆನೂ it is sp3 hybridization. Which of the following products shown by the reaction methoxyethane with HI? Methoxyethane with HI. We already discussed it. Halogen will be attached to lower number of alkyl groups. That is CH3I plus C2H5OH. So among the options, suitable one is D. Ethers are not distilled to dryness for fear of explosion. This is due to formation of oxides, alcohols, ketones, peroxides. Ethers anna ಬಹಳಷ್ಟು ಡಿಸ್ಟಿಲ್ಡ್ ಮಾಡಂಗಿಲ್ಲ ಡ್ರೈನೆಸ್ ಅಲ್ಲಿ, ಬಿಕಾಸ್ ದೇ ಅಂಡರ್ಗೋ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಪೆರಾಕ್ಸೈಡ್ಸ್ which is explosive reaction will take place. So D is the answers. Ethyl iodide reacts with the sodium methoxide to form ethyl methyl ether. Ethyl iodide reacts with sodium methoxide forming ethyl methyl ether. It is an example of SN2 reaction where electrophile attacks to opposite positions of the compound. When vapors of ethyl alcohol are passed over alumina at 523 Kelvin, it forms ethyl alcohol vapors passed over copper or alumina 523 Kelvin. Dehydrogenation takes place, forming aldehydes. Acetaldehyde, generally called as ethanol, UPAC name. Sorry, please. 2 molecules of ethyl alcohol dehydration takes place, forming CH3, CH2O, CH2, CH3. 2:1 ratio. It forms ethers, that is ethoxyethane. Williamson's ether synthesis is an example of haloalkanes treated with sodium ethoxide. So elimination of NaOH. So replacement of OR, that is nucleophilic substitution reaction. In place of halogen, I am replacing a nucleophile, hence it is called nucleophilic substitution reaction. Answer is A. Which of the following reagents can be used for separating mixture of ethyl and alkyl halide? Ether or O R dash, alkyl halide RX. Among these, ethers are reacts with sulfuric acid, Haloalkanes do not react with concentrated sulfuric acid. Remaining things are, this is oxidizing agents. So they do not react with any one. So among all the answers, concentrated sulfuric acid can be used for separation of ethers from haloalkanes. The number of methoxy and ethoxy groups in a compound is determined and estimated by CH3, OCH3 treated with HI. It forms CH3I plus H2O. Here the formation of CH3I, that is halogen, will be tested by Zeisel method, Kolbe's method, Herbig's method, Hoffman's method. As you know, Zeisel method is the only one method which is used to estimation of halogens. So in this one, formation of number of methoxy or ethoxy groups can be estimated by Zeisel method. Diether ether may behave as C2H5O C2H5. This oxygen atom of ether contains a lone pair of electrons. It is a electron donor. Hence, as per the theory, it acts as a Levy's base. Levy's theory prakara electron donate ಮಾಡೋ substances ಅನ್ನ ನಾವು Levy's bases ಅಂತ ಕರಿತೀವಿ. ಈ ಈಥರ್ದಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಇರೋದ್ರಿಂದ ಇಟ್ ಇಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡೋನರ್, ಇಟ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಎ Levy's base. Next, the intermediate formed in aldol condensation. Aldol condensation is formed when alpha carbon atom is present. CH3CHO of one aldehyde, another alcohol. Elimination of water molecule intermediate of compound is CH2 minus CHO. This compound is called carbanion. It further reacts with one more molecule of aldehyde and aldol will be formed. So this compound, intermediate compound, is carbanion. Answer is B. The reaction C2H5OH alcohol with thionyl chloride in presence of pyridine C2H5Cl and SO2 and HCl gas is liberated. This reaction is known as Dargens procedure, Dargens method. In this method, the products, ಮೂರು products ಇದಾವ, ethyl chloride, SO2 plus HCl. SO2 ಮತ್ತು HCl ಎರಡು gaseous state ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ easily escapes out. So C2H5Cl can be prepared easily. Haloalkanes can be prepared easily by Dargens procedure. Next, monochlorination of toluene in sunlight followed by hydrolysis with NaOH yields monochlorotoluene. ಇದು ಟಾಲ್ವಿನ್. ಅದರಲ್ಲಿದ್ದ ಒಂದು ಹೈಡ್ರೋಜನ್ ತೆಗೆದ್ರೆ ಕ್ಲೋರಿನೇಷನ್ ಮಾಡಿದ್ರೆ ಬೆನ್ಸಿಲ್ ಕ್ಲೋರೈಡ್, followed by hydrolysis with NaOH. If this is the benzyl chloride, this compound will be the benzyl alcohol. So monochlorination of toluene in sunlight followed by hydrolysis with NaOH yields to benzyl alcohol. Which of the following reagents cannot be used to oxidize primary alcohols to aldehydes? Primary alcohols lidda aldehydes ಮಾಡ್ಲಕ್ಕ mild oxidizing agents ಬೇಕಾಗ್ತಾವ. Strong oxidizing agents ತಗೊಂಡ್ರೆ they directly converts into carboxylic acids. ಕೆಳಗಿರೋ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ chromic oxide in an anhydrous medium, it is a mild oxidizing agent in which primary alcohol converts into aldehydes. KMnO4 in acidic medium, it is a strong oxidizing agent. ಈ KMnO4 ತಗೊಂಡ್ರೆ primary alcohols directly converts into carboxylic acids. Pyridinium chlorochromate PCC, ಇದನ್ನು mild oxidizing agent. Heat in presence of copper at 573 Kelvin is also dehydrogenation takes place forming aldehydes. So ಯಾವುದನ್ನ ಯೂಸ್ ಮಾಡಬಾರದಪ್ಪ ಅಂದ್ರೆ KMnO4 in acidic medium, it is a strong oxidizing agent where primary alcohols converts into carboxylic acids rather than aldehydes. So answer is B. The most suitable reagent for the conversion of primary alcohols into aldehydes. In the last previous question we have discussed it. KMnO4, K2Cr2O7, chromic oxide, PCC. Suitable reagent. ಈ ಎಲ್ಲ ಮೇಲೆ ಇರೋ 4 ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿನೂ PCC is the better mild oxidizing agent, pyridinium chlorochromate, which converts primary alcohols into aldehydes. On distillation with zinc dust, phenol gives, already we have discussed several times, it is easy method to eliminate OH group forming benzene. So answer is C. Which of the following when sodium phenoxide heated with ethyl iodide? Elimination of NaI forming ethyl phenyl ether. Ethyl phenyl ether. It is also called as phenetol. Another name, market name, commercial name called phenetol. In the reaction, methyl alcohol on oxidation aldehydes. Number of carbon atoms remains the same. Which is further treated with ammonia, CH3OH, on oxidation, HCHO. Further oxidation, HCOOH. So mild or strong ant helilla, so end product will be formic acid. This is further treated with NH3 forming HCOONH4. Ammonium formate. A. Formic acid. B. Ammonium formate. The end product of the reaction, ethyl alcohol, C2H5OH, PCl5, C2H5Cl, KCN, potassium cyanide, C2H5CN, propane nitrile. It is on acid hydrolysis, C2H5COOH. Propanoic acid, 3 carbon atoms, propanoic acid. End product C is propanoic acid. From amongst the following alcohols, the one that would react fastest with concentrated HCl and anhydrous zinc chloride. Concentrated HCl and anhydrous zinc chloride is called Lucas reagent. It immediately reacts with fastest with tertiary alcohol. 2-butanol, CH3, CHOH, CH2, CH3. OH group is attached to carbon atom containing 2 carbon atoms either side. Hence it is secondary. CH3, 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 OL, OH. 2-methyl propane 2-ol. Second carbon atom containing methyl group. Second carbon atom containing OH group. 3 carbon atoms parent. 2-methyl propane 2-ol. OH group attached carbon atom contains 3 carbon atoms. It is a tertiary. So this will react with very fast with Lucas reagent. Third option, 2-methyl propanol. Methyl propanol. This is primary alcohol because OH group attached carbon atom contains only 1 carbon atom. This is primary carbon atom. 1-butanol. This is also primary. Among 4 options, second option is the tertiary alcohol which will react fast with Lucas reagent. So answer is B. Compound A molecular formula C4H10O. On treatment with Lucas reagent at room temperature gives a compound B. When compound B heated with alcoholic KOH, it gives a isobutene. Identify the compounds A and B. At room temperature, it will be definitely the secondary alcohol. A will be the definitely a compound of secondary alcohol, which gives a compound B, that is nothing but secondary haloalkane. I have written based on C4H10O. A compound is secondary alcohol, that is 2-butanol. On treatment with Lucas reagent, room temperature gives a compound B, that is 2-chlorobutane, which is on alcoholic KOH. Alcoholic KOH used for dehydrohalogenation. Halogen from 1 chlorine atom, from 1 carbon atom, hydrogen from alpha carbon atom which contains less number of carbon atom. So obtained product will be CH2 double bond CH single bond CH2 CH3. Isobutene. So options are 2-methyl 1-propanol or and 1-chloro 1-methyl propane. Suitable answer is 2. C6H5CH double bond CH CHO. C6H5 CH double bond CH CH2OH. Aldehyde converting into alcohol. Aldehyde converting into alcohol. That is nothing but reduction. Including double bond. If aldehyde groups are converting into alcohols, then it should be strong oxidizing reducing agents like sodium borohydride, sodium boron hydride. That is strong reducing agent. Aldehydes containing double bond as well as aldehyde groups are converts into alcohol groups. Dehydration of alcohol is an example of alcoholದಲ್ಲಿ dehydration, removal of water molecule is nothing but ಎಲಿಮಿನೇಷನ್ ರಿಯಾಕ್ಷನ್. ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ತೆಗಿತಾ ಇರೋದ್ರಿಂದ ಈ ರಿಯಾಕ್ಷನ್ ಅನ್ನ ಎಲಿಮಿನೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಹೇಳ್ಬೋದು. ಆನ್ಸರ್ ಈಸ್ ಬಿ. ವಿಚ್ ಆಫ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಈಸ್ ನಾಟ್ ಫಾರ್ಮ್ಡ್ ವೆನ್ ಗ್ಲಿಸರಾಲ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ HI? ಗ್ಲಿಸರಾಲ್ CH2OH, CHOH, CH2OH. HI ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದ್ರೆ ಯಾವ ಪ್ರಾಡಕ್ಟ್ ಬರಂಗಿಲ್ಲ ಅಂದ್ರೆ ದಿಸ್ ಪ್ರಾಡಕ್ಟ್ CH2OH, CHI, CH2OH. This product does not take place. All the remaining products takes place with addition of HI, elimination of I2. So answer is C. The product obtained the reaction is phenol when treated with NaOH and further treated with the carbon dioxide and on hydrolysis it forms a salicylic acid. This reaction is called as coal-base reaction. The correct order of acidic strength of the following compounds is phenol, paracrisol, metanitrophenol and paranitrophenol. Acidic strength. Paranitrophenol. Nitro group is electron withdrawing group, which is due to presence of electron withdrawing group, acidic strength is more. Paranitrophenol, D is more. Then afterwards, metanitrophenol, presence of nitro group. Then afterwards, phenol and crisol. In crisol, CH3 group ಇರೋದ್ರಿಂದ acidic strength ಕಡಿಮೆ ಆಗುತ್ತೆ. Because CH3 group is electron donating group. As a result, phenol ಅಲ್ಲಿರೋ acidic strength ಕಡಿಮೆ ಆಗುತ್ತೆ. It is less than the phenol. So A, then B. E order. D, C, A, B. Option A is correct. Phenol treated with zinc dust forms X. That is nothing but benzene. Treated with methyl chloride and anhydrous aluminum chloride. So it forms methyl benzene. Further treated oxidation in presence of alkaline KMnO4. It is a strong oxidizing agent forming benzoic acid. Phenol heated with zinc dust forming benzene. Benzene treated with methyl chloride forming methyl benzene. It is further oxidation forming product benzoic acid. Answer is B. ನಮಸ್ಕಾರ. ನನಗೆ ಈ ಅವಕಾಶ ಕೊಟ್ಟಿರೋ ಪದವಿ ಪೂರ್ವ ಶಿಕ್ಷಣ ಇಲಾಖೆಗೂ ಈ ಆಲ್ಕೋಹಾಲ್ಸ್, ಫಿನಾಲ್ಸ್, ಈಥರ್ಸ್ ಬಗ್ಗೆ ತಮಗೆಲ್ಲ ತಿಳುವಳಿಕೆ ಮಾಡಿದ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಶುಭ ಹಾರೈಸುತ್ತಾ ವಂದನೆಗಳನ್ನು ಸಮರ್ಪಿಸುತ್ತಾ ಇದ್ದೇನೆ. ನಮಸ್ಕಾರ.